Thank you to everyone for joining us today. While we're waiting to start, please take the time to type in the chat window your name and affiliation. We also have information if you wanted to be added to this subcommittee's mailing list. Thank you. Good morning, everyone. We're going to wait a few more minutes before starting the meeting to give people time to join. Please remember to type your name and affiliation into the chat window. And if you're interested in being on our subcommittee mailing list, please send an email to Clara or myself. Our email addresses are on the slide. Happy New Year, everyone. Thank you for attending today. Welcome to the Census for Transportation Planning Annual Subcommittee meeting. We want you to be aware that we will be recording this meeting. My name is Kathy Yu. Clara Rashofsky and I are co-chairs of this subcommittee. I'm a modeler at NCT COG, and Clara is a survey statistician and confidentiality officer at the Bureau of Transportation Statistics. This subcommittee is very interested in census data matters as they relate to transportation planning. Our focus spans the entire spectrum of census-related activities, including applied uses of the data, the content of censuses, collection procedures, and dissemination programs. As part of our goal to promote understanding of census data, census transportation planning products, and other data sources for metropolitan transportation planning, we prepared a relevant lineup of speakers today to update you on important census data issues. Okay. We will be starting off with the 2020 Census Disclosure Avoidance System presented by Michael Haas of the U.S. Census Bureau. We'll follow it up with Urban Area Criteria for the 2020 Census by Jennifer Zanoni of the U.S. Census Bureau. We will also have some updates from Charlene Byrd of the U.S. Census Bureau on the Census Journey to Work, and from Penelope Weinberger of AASHTO on CTPP and AASHTO updates. And we'll close with some final announcements. We ask that everybody stay muted so that we can hear the presentations. I ask that you post any questions you have for the presenters in the chat. Clara will be monitoring the chat, and after each presentation, she'll read through the questions so the presenters can answer them. Michael, did you want to try?
Sure, give me one moment here.
Sure. And while he's doing that, let me tell you a little bit about our first presenter, Michael Haas. Michael Haas is the Senior Advisor for Data Access and Privacy at the U.S. Census Bureau. He is responsible for outreach and engagement with the Census Bureau's data users on issues relating to the impact of privacy protection methodologies and on the accessibility and usability of census data. Prior to joining the Census Bureau, Michael served as a Director of Student Privacy at the U.S. Department of Education. Michael will now present on the 2020 Census Disclosure Avoidance System.
Great, well, thank you so much for having me here today. I'm excited to be talking to you about the confidentiality protections that we're using for the 2020 census, how they differ from the confidentiality protections that we've used for some prior censuses, why we made the change, and what impacts you can expect they might have on your uses of census data. Before I start, I just want to thank all of my colleagues here at the Census Bureau who've contributed to the information that's included in my presentation today. I want to thank our many data users who have been providing feedback throughout the process of our developing our disclosure avoidance system for the 2020 census. That feedback has been invaluable in helping us to improve and optimize our disclosure avoidance procedures. And then finally, I just want to say that any opinions or viewpoints I express today are entirely my own and do not represent the opinions or viewpoints of the U.S. Census Bureau. So the Census Bureau has a very strong commitment to protecting the privacy of our respondents and the confidentiality of our respondents' data. This is a core element of our institutional culture, and it's a necessary one in order for us to be able to collect quality statistics in the first place. The confidentiality of census data is guaranteed under Title 13, Sections 8B and 9, with very strict penalties for any disclosure of identifiable information from the census. But perhaps more importantly, the very quality of the data that we collect is contingent on our ability to protect confidentiality when we release statistics from our censuses and surveys. If the public did not trust us to be able to adequately safeguard their sensitive information, they wouldn't be willing to participate in the census in the first place. So our commitment to confidentiality, our commitment to data stewardship is really at the forefront of our ability to produce quality statistics. Throughout its history, the Census Bureau has been a world leader in the design, research, and implementation of a whole family of statistical methods that can be used to protect confidentiality when you're making public data releases. Over the decades, as the quantity of data that we're publishing and the detail or granularity of that data have increased, and as privacy threats have increased over the years, we've had to update, modify, and improve those statistical methods in order to keep pace. For the last several decades, for particularly the 2000 and 2010 censuses, that meant using a technique known as swapping, where we were swapping entire households from one geographic area to another in order to better protect the confidentiality of the individuals residing in those households. For the 2020 census, our adoption of an approach known as differential privacy or formal privacy, which I'll be talking more about in a moment, is really just the latest in what has been a long history of continuous innovation at the Census Bureau in our approaches to protecting confidentiality. The real challenge that we face is that it's been demonstrated that anytime you release any statistic, any number at all that's derived from a confidential data source, releasing that statistic is going to reveal or leak a tiny bit of confidential information in the process. And what that means is that if you release too many statistics too accurately, well, then eventually you will have revealed all of the underlying confidential information in the process. And so this is what we're trying to protect against. And our ability to protect against this is made even more difficult in the face of kind of today's information age. Information about us is collected by all sorts of different entities out there. The businesses we interact with, financial companies that have all of our information, social media, and much, much more. And what this means is that there are very rich third-party data sources out there that can be used to try to pick out specific individuals in the official statistics that the Census Bureau publishes. And this is compounded by the fact that computers have increased in power and capabilities to a monumental degree over the last decade. And new machine learning algorithms and powerful cloud computing platforms mean that it's now very easy and cheap for a would-be attacker to be able to leverage all of that third-party information that's also available in an attempt to re-identify specific respondents to the census. And so this is what we're trying to protect against. Now, historically, most confidentiality protections that statistical agencies have used have really focused the bulk of their attention on preventing re-identification of microdata releases, data products where you're releasing individual level information. For those of you who are familiar, for example, with the public use microdata files, that would be an example of a microdata release. And so a lot of attention has been paid over the years to confidentiality protections for those microdata releases, because that's where it's easiest to re-identify specific individuals. So if you look at this example I have here, the data on the right might be a microdata release from a census or survey. And you'll notice we've stripped off, in this particular case, we've stripped off your obvious identifiers of individuals. There's no name, there's no address. We just have kind of the basic demographic information for those individuals. Unfortunately, it's actually quite easy in many cases to essentially re-identify individuals by linking records using other data elements that are included in the file, confidentiality of those individuals that become kind of pseudo-identifiers. So in this particular example, you could link the confidential data, the public data release that an agency might make to third-party commercial information by linking the individual's location, their block ID, their age, and their sex. So for example, like the external data on the left could be voter registration lists for a block or financial transaction information for that area. And by linking block age and sex, you're now able to reattach, in this case, Jane, Joe, and John's names and addresses to the public data release that the agency made. And so you've now learned Jane, Joe, and John's race and relationship status. This is what's known as re-identification or a re-identification attack. And much of the approach to disclosure avoidance over the years has really focused on trying to prevent this type of attack on microdata records. Tabular data, aggregate tabular data, have also been protected, but they've usually had much less stringent privacy protections because historically it's been seen as much more difficult to re-identify individuals in aggregated data. The problem is the world has changed. So there is now a kind of a new vector of attack that can be made on public data releases, and that's a re-identification attack on aggregated tabular data. And you can kind of think of this like a giant game of Sudoku, if you will. With a game of Sudoku, if you're familiar with Sudoku puzzles, if you've got enough numbers pre-populated into the grid, well, then eventually there's going to be one and only one solution to the puzzle, only one way that you could fill in the rest of it. Well, the same holds true for aggregate tabular data. If you release enough data tables that are all derived from the same underlying source, and you've kind of published them sliced and diced different ways by characteristics, well, then eventually there's going to be one and only one set of individual level records that could have yielded all of those aggregate tabular releases. And computers can actually solve for this quite easily. They can take the assembly of data tables that you're publishing and solve for the underlying set of individual level records that could have yielded all of those aggregate tabular results. And this is known as database reconstruction, or a reconstruction embedded re-identification attack. And this is a new vector that is particularly worrisome for statistical agencies to be able to protect against, because it means rethinking how we approach confidentiality protections for aggregated data releases. So with this new vector of attack in mind, a few years back, the Census Bureau decided to conduct some simulated attacks on our own public data releases from the 2010 census to see just how well the confidentiality protections that we used back in 2010 are able to stand up to these new types of confidentiality attacks. So to give you an idea, the 2010 census collected a handful of attributes on the approximately 309 million people that were enumerated in the 2010 census. That gave us about 1.9 billion confidential data points that we had to protect. But by comparison, the suite of data products that the Census Bureau released following the 2010 census contained over 150 billion independent statistics that were all calculated off of those 1.9 billion confidential data points. And if you recall a moment ago, I said anytime you're releasing any statistic that's derived from a confidential data source, you're going to be revealing or leaking a tiny bit of confidential information in the process that could be used or leveraged in a reconstruction attack. We wanted to see if those 150 billion statistics that we released after the 2010 census were enough to be able to reconstruct and re-identify specific individuals from the publicly released data. And the results of these simulated attacks were rather eye-opening and alarming. We were able to reconstruct individual level information. We were able to reconstruct all 309 million records for all 6 million inhabited blocks in the US. Looking at the content of those records, we were able to reconstruct block location, sex, age in years, plus or minus 1 year, race to the 63 OMB race categories, and ethnicity for 71% of the US population, or about 219 million people. But how accurate were these reconstructions? So to test that, we then tried linking those reconstructed individual level records to commercially available data from the time period, and then seeing, okay, were those re-identifications correct or not? And what we found was, yes, we had in fact accurately re-identified on all variables 52 million people, or about 17% of the US population. And this was just using a small portion of the publicly released data from the 2010 census. So this was, as I said, absolutely an eye-opener for the Census Bureau. It showed that the approaches to confidentiality protection for the aggregated tabular data products that we'd released for prior censuses were no longer sufficient to be able to counter these new vectors, these new methods of attack on our publicly released data. So the Census Bureau decided that in order to meet our legal and ethical obligations to safeguard respondent privacy and confidentiality, we had to change our approach to confidentiality protection, change our approach to disclosure avoidance in order to keep pace with these new threats. So to understand kind of what these changes mean and like what the new approach that we're taking is, it's helpful to understand a little bit about how disclosure avoidance methods work in general. So disclosure avoidance historically has sought to make re-identification attacks more difficult by doing one or more of three basic things. They seek to either reduce the precision of the data that you're publishing, they can remove vulnerable records from the data that you're publishing, or you can add uncertainty to the data that you're publishing, all in an attempt to reduce the attacker's ability either to reconstruct and re-identify in the first place, or to have any confidence that their re-identifications are correct. And commonly used kind of traditional techniques for disclosure avoidance include things like suppression of cells within data tables, rounding values in your release data, recoding the data at the top or the bottom of the distribution, sampling from a larger population, swapping records across geographies like we did for the 2000 and 2010 censuses, or other forms of injecting noise or uncertainty into the results. Now, the problem with these approaches historically is that they impose a fundamental trade-off between the degree of privacy protection on the one hand and the resulting accuracy or availability of data on the other. This isn't a side effect of disclosure avoidance, it's how disclosure avoidance works. You have to have this trade-off in order to protect privacy. So the stronger your privacy protections, the more of an impact it'll have on the data. The more accurate the data that you want to release, the weaker the privacy protections will need to be. And the parameters of your disclosure avoidance method determines kind of where on this balance you're going to fall. Things like your swapping rates, your noise injection parameters, your cell suppression thresholds, and so on, decide, okay, how strong will the privacy protections be with corresponding impact on the data, or how accurate will the data be with a corresponding reduction in the strength of your privacy protections. But practitioners of kind of traditional approaches to disclosure avoidance have had a kind of difficult time doing this, because most disclosure avoidance methods don't provide you the ability to really quantify the strength of the privacy protections that you're putting into place. Some have called disclosure avoidance, as it's historically been practiced, kind of the occult sciences in many ways. It's done based largely on expert opinion, subject matter experts, kind of impressions of the quantity of protection that are needed, or the likelihood of vulnerability. But when faced with kind of rising privacy risks, these practitioners have had to kind of eyeball their implementations and kind of change their parameters to try to keep pace with growing threats, but again, without an ability to really quantify how much is necessary. And what that's meant is that historically, it's been largely a scattershot solution to confidentiality protection that tends to overprotect some records, making some of the data less accurate than it could be, while also simultaneously underprotecting some of your more vulnerable records, essentially making them still vulnerable to re-identification. And so kind of with all of that in mind, the challenges of kind of traditional approaches to confidentiality protection in mind, this brings us to our adoption of what's known as differential privacy for the 2020 census. Now, it's important to know that differential privacy is not a disclosure avoidance method per se, the same way that swapping or cell suppression is a statistical technique for confidentiality protections. Rather, differential privacy is best thought of as like a privacy risk accounting framework that allows you to quantify the privacy risk or the degree of privacy protection in very precise ways. Every individual that's included in any statistic that you publish is going to contribute towards that statistic's value. And as I mentioned before, every time you publish a statistic that's derived from a confidential data source, you're going to be leaking a tiny bit of confidential information about all the individuals that are reflected in that statistic. So differential privacy, as this kind of privacy risk accounting framework, allows you to assess each individual's contribution to each of the statistics that you want to publish. And by assessing that contribution, it allows you to measure how much information about each of those individuals is going to leak in the statistics that you want to release. So when you combine this kind of privacy risk accounting framework, this ability to measure individuals' contribution to statistics and the leakage of their confidential information and the resulting data, when you combine that with a disclosure avoidance method like noise injection, where you're introducing uncertainty into the data, differential privacy allows you to really precisely control the amount of private information leakage in the statistics that you want to release. It allows you to control exactly how much confidentiality risk or protection the resulting data will have. And this offers a number of really substantial benefits over traditional approaches to confidentiality protection that I've discussed before. For starters, differentially private approaches are infinitely tunable and very precise. You can think of the implementation parameters as a massive set of dials that can be set anywhere on that spectrum, from perfect privacy at the one extreme to perfect accuracy of the data at the other extreme. Perhaps more importantly, in kind of this uncertain world about what new privacy threats are going to arise in the future, the privacy guarantee of differentially private approaches is mathematically provable and it's future-proof. So you don't have to worry about what advancements in machine learning algorithms are going to occur next year, or what new third-party data might be available to leverage in an attack down the road. And lastly, the precise calibration, the fact that you're actually quantifying all of this and that you can set those dials very precisely, enables you to achieve optimal data accuracy for any given level of privacy protection. This is in contrast to that kind of scattershot approach that I mentioned before, where you're overprotecting some records and underprotecting others. So to understand what this means for the 2020 census, it's helpful to understand kind of how the different data products fit together. We have a number of data products that are going to be all generated from the 2020 census data. And we've kind of internally and kind of informally divided these into three different buckets. And colloquially within the Census Bureau, we refer to these as kind of the Group 1 products, the Group 2 products, and the Group 3 products. This first group includes the Public Law 94-171 Redistricting Data Summary file, which we released back in August. It includes the demographic profile and the demographic and housing characteristics file, which will be the next of the major data products to be released. The second group are the detailed race and detailed ethnicity and detailed tribal data that will be included in what's known as the detailed demographic and housing characteristics file. And then the third group is kind of everything else. And those are all to be determined data products that might include public use microdata, special tabulations from the 2020 census, researcher access through the Federal Statistical Research Data Centers, and other kind of out-year uses of the 2020 census data. So the 2020 census disclosure avoidance system is kind of the larger system that we're using to protect confidentiality for the 2020 census. That's composed of a number of different algorithms, and those algorithms are being used to protect different data products. So the Group 1 data products are being protected using what's known as the top-down algorithm. And this was the algorithm that was used to protect the redistricting data that was released last summer, and that will be used to protect the demographic and housing characteristics file later this year. And the top-down algorithm works by essentially injecting noise into the data and producing the output of the algorithm is privacy-protected microdata, individual level records, that can be then tabulated by the decennial census tabulation systems. The second group, the detailed demographic and housing characteristics file, are being protected using other differentially private algorithms that are going to produce privacy-protected tabulations directly. So they're going to skip that kind of privacy-protected microdata step. And then the third group can use any of these existing algorithms or other formerly private solutions. So to understand kind of what all this means, it's helpful to kind of look at what the parameters that we have to set in the algorithm's implementations are. And the most fundamental of those parameters is what's known as the privacy loss budget. So I mentioned a moment ago that any disclosure avoidance mechanism is going to impose this fundamental trade-off between data protection on the one hand and data accuracy or availability or fitness for use on the other. It's this unavoidable trade-off between the two. Well, you can imagine that trade-off as represented on a spectrum, with the world of perfect privacy and completely useless data at the one extreme, and the world of perfectly accurate data with no privacy protections at all at the other extreme. And what you want to do is you want to find a point in between those two extremes where the data are sufficiently accurate to meet their intended uses, while also being sufficiently protected to meet your legal and ethical obligations to protect respondent confidentiality. And once you've picked that point on the spectrum, that point can be quantified, and you can call that your privacy loss budget. And you'll see this abbreviated as PLB, or by the Greek letters epsilon or rho, depending on where you're looking. And the privacy loss budget can be thought of kind of like a monetary budget. The higher your privacy loss budget, the more accurate the data are going to be, but the less privacy protection you're willing to have. The lower your privacy loss budget, the less protection you're willing to give up, like the more protection you want to have, and the less accurate the resulting data will be. So higher PLB, more accurate data, weaker protections; lower privacy loss budget, stronger protections, but less accurate data. Once you've determined that privacy loss budget, then needs to be kind of spent on the different data that you want to release. And so you can allocate shares of your privacy loss budget to the different data products, the different statistics that you want to publish. And again, the larger the share you give to a particular set of data, the more accurate those data will be. The smaller the share, the less accurate the data will be. And so we can allocate shares of this global privacy loss budget to the different data products that we're going to be producing. And all of those shares together form your global privacy protections for the 2020 census. But then within each of the data products, you then have to allocate further shares of your privacy loss budget to all of the statistics that you have to generate to create that data product. And again, the more privacy loss budget you give to a particular set of statistics or tabulations, the greater the accuracy. The lower the share of the privacy loss budget, the more noise is going to be injected into those statistics, and the less accurate the resulting data will be. And so what you can see here are the shares of privacy loss budget that we allocated to the different tabulations that comprised the redistricting data that was released last summer. So we were allocating shares by statistics at different geographic levels, so US, state, county, tract, block group, and block, and by the various queries that we were essentially using to tabulate from the underlying confidential data when we were injecting the noise. And so for each of these are all fractions of the privacy loss budget, and the higher the fraction, the more accurate those particular statistics would be. The lower the fraction, the stronger the privacy protection, but the less accurate the result will be, the more noise is injected. And so these were the allocations, as I said, for the redistricting data. this was the result of heavy tuning of the system. There's no right answer when it comes to this. You want to kind of experiment to find the optimal allocation of privacy loss budget, again, to meet the intended priority uses of the resulting data, while staying within this broader privacy loss budget that you've set to protect confidentiality. And so assigning these shares, determining how much to wait for state level statistics versus block level statistics, for example, or how much privacy loss budget should be given to race by Hispanic origin versus how much should be given to total population or voting age population. Those shares were determined through extensive tuning that we did that was informed by our engagement with our data user community over the months preceding the production of the redistricting data. Over the past 2 years, leading up to the release of the redistricting data, the Census Bureau released 6 sets of what we call demonstration data, where we took 2010 census data and ran it through different iterations of the top-down algorithm in our 2020 census disclosure avoidance system. And what this allowed was it allowed data users to kind of compare, excuse me, differentially private versions of the 2010 census to the published statistics from the 2010 census that were protected using swapping. And they could see, okay, with this set of parameters, this set of privacy loss budget allocations, these data are this accurate relative to those, or these particular tabulations are lacking in fitness for use for this particular use case. And they provide, our data users kind of did extensive evaluation of these demonstration data and provide us extensive feedback that helped us better tune the system and to adjust our algorithms in order to meet our data users' needs when we finally set the production settings for the algorithm that was used to produce the redistricting data. We are going to follow a similar process for the production of the next of the major data products, the demographic and housing characteristics file. And so we're again going to be relying heavily on engagement with our data users to set those parameters for the production of the DHC. And that engagement is going to follow roughly a 3-pronged approach. Engagement and education with our data users, like where are we going with differential privacy and the demographic and housing characteristics file? How did we get there? Feedback and listening, like finding out how our data users are using these data, because knowing those uses and knowing what their fitness for use needs are is going to help us better tune the system. And then perhaps most importantly, demonstration and implementation. So again, producing at least 2 sets of demonstration data products based on the DHC to allow data users to go in and compare differentially private versions of the DHC data to the published tabulations from 2010 to see, do these meet our needs or not? Do we need to adjust those privacy loss budget allocations, etc. So we will be releasing at least 2 sets of these demonstration data over the coming months. We're also going to be continuing our extensive engagement with a variety of advisory and stakeholder groups, including our federal advisory committees, tribal consultations with American Indian Alaska Native tribal leaders, work with the experts on the Committee of National Statistics, work through the state data centers and Census Information Center networks, and many, many more. To give you a rough idea of kind of the notional timeline for all of this moving forward, this past fall, we released an updated set of the proposed tables that are proposed for inclusion in the demographic and housing characteristics file. That was to allow data users to provide feedback on whether that suite of proposed tables at particular levels of detail and for particular levels of geography were sufficient to meet our data users' needs or not. And we did receive extensive feedback from our stakeholder community on those proposed tables for the DHC. This winter, so over the next couple months, we're going to be releasing our first set of demonstration data for the DHC, again, using 2010 census data run through our 2020 census algorithms. We'll collect feedback and fitness for use assessments from our data users based on those demonstration data, adjust our algorithms, continue to tune those privacy loss budget allocations. Then in the spring, we'll release a second set of demonstration data reflecting the feedback we've received and further improvements to the algorithms. We're going to be doing another public workshop with the Committee on National Statistics, similar to the one that we held back in December of 2019. And again, we'll collect feedback based on those assessments from the demonstration data, and that feedback will then inform the final production settings that will be used to produce the DHC file when we go into production in summer of this year. If you would like to stay informed on all of the work that we're doing on our 2020 Census disclosure avoidance system and our 2020 Census data products, I highly recommend subscribing to our newsletter. We send out a new newsletter every couple of weeks or so, and it's where you can get all the kind of latest and greatest breaking news on our efforts. We also just released a few months ago the first in what's going to be a series of handbooks on differential privacy and the 2020 census. This one was disclosure avoidance for the 2020 census and introduction, particularly with focus on DP in the context of the redistricting data that was released back in August. That's available on our website or via this link. We have a wealth of information available on our website. We've got archived presentations, videos, frequently asked questions, issue papers, all sorts of resources. It's a great compendium of kind of every level of technical information you might want, from super high level down to the nitty gritty of the technical implementation, links to our code base, links to all of our technical documentation, etc. So that's all available on our website. You can just go to census.gov and search disclosure avoidance. We also, for those of you who might have to explain differential privacy to less technical audiences, we have a wonderful video that we did in partnership with the communications group that did most of our 2020 census advertising campaigns. This is a great introductory video on what differential privacy is and how it works. I do highly suggest checking that out. That's also available on our website. And with that, I will stop, and I'm happy to take any questions that you have. I know some came in in the chat during the presentation. So.
Thank you, Michael. This is Clara, the other co-chair of the subcommittee. We did have a couple of questions come in, and I encourage anybody who has some questions that are just occurring to you now to also post those in the chat. For Michael. The first question was sort of a two-part because somebody actually answered it initially in the chat about whether the block ID is included in the PLUMS file, and the answer is no. And I think the sort of the follow-up question is about whether, and this is one of your earlier slides about identifying individuals using both private data sets as well as census data sets, whether the same point could be made with without using the block ID attribute. And I would actually extend that to any small geographical identifier, be that, lat long, a specific address, block ID, tract ID.
So I'm not entirely sure what the question was there.
Sorry, yeah. It was the slide where you had Joe Citizen.
Yeah, no, I know the slide.
Yeah.
I'm just trying to figure out what the question was.
I think the question is whether the attributes, even without the geographic identifier, could be matched up without the block identifiers specifically. And
okay. So
yeah.
So to give you an idea, so that's a great question. To give you an idea, in the simulated attack that we did on our own published data, the key attributes that allowed us to re-identify those 52 million people accurately were block location, sex, and age. And those came from the redistricting data tables P1 through P4 of the redistricting data at the block level, and the sex by age tables at the tract level from SF1. And so because the redistricting data include such detailed information down to the block, that gives you block location, it gives you the number of people in the block, and it gives you the basic demographics. When you combine that with the sex by age tables that are included in SF1, that's sufficient information to be able to re-identify individuals, because there's only so many permutations there, if you will.
Thank you. Yeah, and I guess, if you have the address of the individual rather than the block ID, you can just roll that up to the block ID, which does essentially the same thing.
Exactly. Yeah.
The next question is more of a theoretical question in terms of a future research, but all this makes me wonder if maybe the private data might not be better than the publicly released stuff, especially if they are doing some good, sophisticated re-identification, et cetera. I wonder if there's a research question here. So I guess I would transfer that. Oh, go ahead.
That's actually an excellent question, and it's one that does come up a fair amount. Like, there is very rich information available through commercial sources. There's no question about that, but it doesn't have the coverage of the census. The census includes information for segments of the population that typically are not well represented in those commercial data files. Groups like children, groups like those without financial accounts. Those are the individuals for whom records in the commercial data are either of poor quality or don't exist at all. So you couldn't do a very effective census using exclusively commercially available data, because you'd either be missing whole segments of the population, or the data quality would be too low to get reliable results. But I mean, there's certainly, the richness of those data is what poses such a threat to us, and so you have to kind of think of both together as the suite of information that an attacker could use to re-identify individuals.
Thanks, that was a great answer. The next question we have is, we've seen performance metrics, our measurements of distortion for the 2010 census data fed through the disclosure privacy process. Are there the same performance metrics for 2020 census? Not finding it on census.gov.
Okay, so short answer, no. Because generating those would require further expenditure of privacy loss budget. Essentially, anytime you're taking any query off of the actual confidential data, you have to expend privacy loss budget in the process. So we did, however, release a final set of demonstration data and detailed summary metrics using the actual production settings that were used to produce the 2020 redistricting data. And the idea of those is, those were the final algorithm settings, the final privacy loss budget allocations that were used to produce the actual 2020 data. So that allows people to do their own assessments of, okay, this is the anticipated amount of error that would be reflected in any particular statistic at any particular level of geography. And we will be producing more detailed kind of assessments of those over the coming weeks and months. But yeah, like, producing those detailed summary metrics off of the actual 2020 data would further expend privacy loss budget, which would mean you'd have less privacy loss budget available for actually producing statistics. So there's a trade-off there, but for the time being, your accuracy assessments are going to have to use that final set of demonstration data using the 2010 census. Claire, I think you're muted.
Yes, I am. I tried to click it and failed. So thank you for that excellent answer. Our next question is there a guarantee that differential privacy is non-reversible?
That it's non-reversible, yes, because with a caveat. The security of your system, the security of any differentially private system, is only going to be as good as your code implementation and the security of your random numbers. Those of you who have tech backgrounds will know that there's pretty much no such thing as a truly random number generated by computers. Instead, we have like pseudo random numbers. This was a big challenge, because in order to implement differential privacy on something the scale of the census, we had to be generating trillions and trillions of independent random numbers or do that. So being able to ensure that the randomness of our random numbers couldn't be reverse engineered was a major implementation challenge. And we actually worked with several outside groups of scientists and experts to ensure that our random numbers were in fact secure. So that was one implementation challenge there. As for the security of the code, making sure that our code was actually implementing things the way it needed to, we went through extensive outside peer review of our code by outside expert groups. And we also published our code so that others could kind of dig in and make sure that it was doing things the way it was supposed to. And all of our code is available on GitHub. You can get the link via that disclosure avoidance update page. But assuming those two things, assuming the security of your code and security of your random numbers, then differential privacy can't be reversed. Now, does that mean that you don't have any privacy risk? Absolutely not. Again, what differential privacy does is it's this accounting framework that allows you to decide where on that spectrum of privacy to accuracy you want to be, and it controls information loss. I mean, you could have a differentially private system with an enormously high privacy loss budget that effectively reveals all of the confidential data because you've set your privacy loss budget high enough. In reality, we're setting the privacy loss budget much, much lower than that in order to provide confidentiality guarantees, and that sets an upper bound on how much information loss can occur, how much confidential information loss can occur through the published statistics. Does that mean that re-identification is impossible? No, it means that it's controlled. It means the risk is controlled by where you set that privacy loss budget.
Thank you. Okay, we have several more questions and we are running short on time, so I may not get to all of the questions. And I'll just say at this point, any questions that we don't get to today, we will email to Michael for responses and then send that back out to all of you for whom we have email addresses for. So if you want to get those responses, send Kathy and me an email about getting onto our mailing list. But I think we have time for one more question, which is, how is the imputation of answers to questions not responded to affect the estimated risk of disclosure? Questions that are not answered is at least a known quantity to Bureau staff. Unknown is which responses are not accurate. But tell us there's a gap between theoretical and actual risk of release of confidential data. And let me know if you need me to read that again.
Let me actually, is that in the chat? Oh, here we go. I just want to read it so that I can. Okay, so that's a great question, and it's one that has come up a number of times. The issue of imputation is an important one. Like I've gotten a lot of data users over the last couple of years who say like, oh, well, if an answer is imputed, then you shouldn't be concerned about the privacy protections for it. And the short answer to that is no, that's not true, because the imputed responses still contain confidential information because for two reasons. The first is they are derived from actual census responses. Like values are not imputed out of thin air. They're imputed based on similarly situated individuals or similarly situated facilities in there. And so there is confidential information included there. Moreover, a lot of that is also kind of imputed based on kind of other sources. So you do have to be concerned about the confidentiality of imputed records, and that's something that our disclosure avoidance system does in fact address. They're all treated as response values, and so they all get confidentiality protection.
Great, thank you. I think we're going to wrap up the questions for Michael's presentation. Thank you so much, Michael. That was an excellent and very informative presentation. But we want to make sure we have time.
Thank you so much for having me.
Yep. I'm going to kick it back over to you, Kathy.
Yes, thank you, Michael, for the presentation. Our next presentation will be on urban areas given by Jennifer Zanoni. So Jennifer, do you want to start sharing your presentation? Jennifer is a geographer with the US Census Bureau, where she's the project manager for the 2020 Urban Areas Delineation. She has a Bachelor of Science in Geoenvironmental Studies from Shippensburg University of Pennsylvania and a Master of Science in Applied Geospatial Sciences from Northern Arizona University. Jennifer came to the Census Bureau in 2016 after more than 10 years. After more than 10 years working in geographic information systems within local government, nonprofit, and defense industries. She lives in Virginia with her chocolate lab, Mia. So on to you, Jennifer.
Thank you. All right, let me get this, I can see it. Okay, so thank you for having me. I'm Jennifer Zanoni. I'm a geographer at the Census Bureau. A number of you have probably heard me talk about urban areas over the last year. And what I'm going to talk about today is the final criteria for the census for the 2020 delineation. So I'm going to start here with basically this is going to be the flow of the final criteria. If you've heard me talk in the last year, you've probably heard me talking about what we proposed. That came out last February in a Federal Register notice. And there will be some pretty big changes to what we had proposed based on the feedback that we've received and testing that we've done. So some of this will look familiar to you and some of this will be new. And I'll try to highlight the things like the big changes that we've made. So to start with, we tried to come up with some new terminology to better represent the different stages of the criteria and what was being created in that stage. So the initial qualification, those blocks that are qualifying, we're going to call them eligible block aggregation, so EBA. So you'll hear me talk about that over the course of this presentation, and that's a new term that we've come up with. This qualification is basically the building block for the whole urban areas. These are being built off of housing unit density, impervious criteria, and group quarter criteria. You'll see here we've raised the housing unit density for this stage to 475. And the reason we raised it was because we're actually introducing 3 different housing unit densities. So don't be too scared yet. So using housing unit density, you've probably heard me talk a couple of times about why we're switching to using housing unit densities. Like Michael just talked about, with the differential privacy methods that the Census Bureau are using for 2020, the block level housing unit counts will be invariant. So that was one reason why we switched from using population counts. Another is that it's a better representation of what's actually happening on the landscape. You have places that don't have year-round population but have seasonal population and have all of the same infrastructure associated with them as a place that does have a higher year-round population. So that lets us capture that a little bit better. And if we choose to, we could be able to update the urban areas more frequently. Right now, we only do it every 10 years after a decennial census, but it could be possible for us to do them, say, every 5 years to capture the development that's been happening. For impervious, this is pretty similar to what was proposed and what was done in 2010. The only change that we're making for the final criteria is that we're going to use NOAA's Coastal Change Analysis Program land cover for certain parts of the country. So Alaska and the continental US, we're going to use the NLCD, and then Hawaii, Puerto Rico, and the island areas will use CCAP. That's just because there's more recent data available for those areas. So for any of them, we'll use whatever the most recent vintage is, and we'll use that for impervious. We'll also use it for the wetlands and water that we use for exempted territory, and I'll talk about that a little later. And group quarters. So a group quarter is not considered a housing unit. It is a place where multiple people reside in one location. So a residence hall, a nursing facility, barracks, prisons and jails, that kind of thing. This wasn't an issue in previous urban area delineations because we use population density, and these locations naturally have a high population density, the blocks that contain them. Switching to housing units, we had to incorporate some new criteria to make sure that we were properly capturing them. So this is going to be the only place in the criteria that we're going to have to use a population density. So we're going to, every block that has a group quarter must have a population density of 500 people per square mile to qualify. So say this is an example of what the delineation will look like. These are, that initial qualification, the EBA, as we're calling them. We're going to identify initial urban cores. This is going to help us build out the delineation further along. And this part is going to help us decide what's going to be hopped or jumped from. And I'll talk about that next. But what we're going to look for is these EBAs that have at least 500 housing units. We're going to consider that an initial urban core. We're going to then run enclaves. So if you see the holes that are still remaining in the urban areas, those are what we call enclaves. And we have an enclave rule that will fill them in if they're less than 5 square miles or and completely surrounded by already qualifying urban territory. So the EBAs that don't meet this initial urban core criteria, they don't have 500 housing units, they'll still remain in the delineation process. They can be hopped or jumped to, they could be included in other ways, but they won't be hopped or jumped from. So the hopper jump is just pretty similar to what we had proposed in the proposed criteria. We're reducing the jump distance down to a 1.5 mile connection that's along a roadway. And the destination, what's being jumped to, must have at least 10 housing units. A hop also along a roadway, you can hop as many times as you want and hop until you exhaust yourself. That's a 1/2 mile connection. And again, it must have at least 10 housing units. So again, we're trying to come up with names for the ends of each delineation phase so that it makes sense when we refer back to them. So everything that continues past this phase, we're going to call a core EBA. I talked about how we're going to use the land cover data for exempted territory. That basically takes place in the hop or jump criteria section. That extends that hop or jump up to 5 miles if it's crossing water or wetlands that are basically undevelopable. That's the reason why development hasn't occurred, is because there's water or wetlands in the way. So we will use that land cover to determine where the water and wetlands are and extend the jump or hop up to 5 miles. Again, what we had proposed that we're keeping the same is that we're not going to include those corridors. So you can see in the map, there's development on the left and development on the right. And the corridor in between doesn't have really any development. It's basically farmland. We're not going to include those corridors. So we will have discontiguous or multi-part urban areas. So this is new from the proposed criteria, and I mentioned that we're going to use multiple housing unit densities. We're going to add in additional census blocks with 200 people per house, 200 housing unit density to better connect the urban areas and smooth them out a little bit. What we found in testing was that we have the center of the suburbs, which just because of the way that census blocks are created, the boundaries, they have a higher housing unit density in the middle of a subdivision than you do on the outside of the subdivision, because those are in larger blocks. Well, this was kind of creating a big mess of what we call cycles. We had a lot of cycles per urban area. And our solution was to have one low housing unit density that we would use to fill in the area around the other qualifying area. So by applying that, we've connected all of these areas that you can see down here, the dark pink and the grays. And then what we'll do is, after we use the low density fill criteria, any of those EBAs that still exist that don't have at least 50 housing units, we're going to remove them from delineation. So we're going to remove this really small housing unit count cycles from each urban area. The next step is the non-residential step. So we've moved airports into this step because it just seemed like a natural fit. So cargo or passenger airports from the FAA in a 9-year period, if they averaged out at least 2,500 enplanement, we include them. Impervious surface, again, we found that a lot of development happens on the outside of an urban area, places like shopping centers, big box stores, and industrial parks. We wanted to be able to capture those, so we run Impervious again. And then we're adding in new criteria for places that don't meet that Impervious criteria because either the block is too large or maybe it has more tree cover, but it has a lot of jobs associated with it. We're going to add in blocks that contain at least, or EBAs, I should say. This is could be a collection of blocks that have at least 1,000 commuter destinations, and that's using the LEHD data. And I'll talk about that more later in the delineation process. We're going to run enclaves one more time just to make sure that there's no holes that we've created in the last few steps. And then we're going to move into indentations. Indentations were in the 2010 delineation, and when we had created the proposed criteria, we didn't include them because we were creating discontiguous urban areas anyway, and we weren't sure that we needed them. Well, during testing and got some feedback about that, and basically indentations help us to both capture urban waterways and smooth out the urban areas a little bit. Otherwise, we end up with really crazy looking spider webs sort of going into the urban area. And that would be parts of it that wouldn't be considered urban unless we did the indentations. So we will run indentations to help smooth out the urban areas and capture the waterways that are within them. And then we will move on to merging. So merging is just for those core EBAs that are close to each other, 1/4 of a mile apart, and that has a high flow of commuters in one direction. So you have a lot of at least 50% worker flow from one core EBA to the other. And that's the case, we'll merge them together. If they are further apart or they don't have that worker flow, we will not merge them and they'll stay separate core EBAs. Another new part of the criteria I mentioned, we're having multiple housing unit densities that we're using. This is the final one, 1275. This is where we're making sure that each urban area has a dense downtown area, like a dense core, if you want to consider it like that. So we're going to do a check for a high density nucleus. This is using the 1275 housing units, and it needs to have at least 500 housing units within that 1275 block. So it could be an agglomeration of blocks using the impervious or the housing unit density, but the ones within the housing unit need to have at least 500 housing units total to count as a high density nucleus. So once we've identified all the high density nuclei, this is basically the last step of determining whether an area is going to qualify as urban or not. So we have the core EBAs that we have that have a high density nucleus, and then the minimum threshold to qualify. So we had proposed 10,000 or 4,000 housing units. Based on feedback, we decided to lower that to 5,000. So 5,000 persons or 2,000 housing units. So as long as it has a high density nucleus and meets that threshold, it will qualify as an urban area. And we're going to call them an urban area aggregation because we still need to look at splitting them. Anything that does not qualify is removed from the delineation process. Splitting. So we've basically kept this pretty similar to what we proposed. We have tried to simplify it a bit, but it's still a pretty complicated process. We're going to be using the LEHD data, and this is the longitudinal employer household dynamics data. So it's worker flows. Where do people live? Where do they work? And this is what we are going to use for that non-residential step that I had mentioned earlier, where it needs to have 1,000 job destinations. This is what we're going to be using for that. So the first thing that we're going to do is we're going to evaluate which of these aggregations actually need to be split. And there's two ways that this could happen. The first is that it encompasses more than one 2010 urban area. And if it has that intersection between the 2020 aggregation and the 20th area, then we will find a place to split it. We'll also look at splitting where multiple of the core EBAs were connected using that low density fill. That's if each core contains a high density nucleus and each core has at least 25% internal worker flow. So a lot of people live and work there. So once we've decided that we are going to split an urban area, we're going to use the Leiden algorithm to create, and we're going to do 3 iterations of that. And I'm going to show you sort of what that looks like in an example here of Central Florida. So you can see in the gray, that's a test area of what the 2020 agglomeration would look like if there were no splits in place. And in red, we have all of the 2010 urban area boundaries. So we can see there would be quite a few splits that would need to happen here. So to show you what the partitions look like, this is level 1 of the partitions created with the LEHD data. This is level 2 and level 3. So you can see you get like fine grain, more neighborhood delineations and boundaries with the level 3 partitions. And I'll show you one a little closer. We'll look at Orlando. So this is the partitions just clipped to the 2010 Orlando boundary, so you could see what they look like a little bit better. So this is level 2, and again, level 3. So then what we'll do for each place that we determine that we need a split, this is again Orlando and Kissimmee. So Orlando has the lines, the lines overlay, and then Kissimmee has the polka dot overlay. And the partitions are underlaying it in the multiple different colors. What we're going to do is assign and group the partitions based on what percentage of the population of that partition overlaps with the 2010 area. So if the partition has 90% of the population of the intersecting area, or if 90% of the population of the partition is within an intersecting area. So those sound very similar, but one is the population of the partition, one is the population of the intersecting area. And so if either one of those is 90%, it will be assigned, they'll be grouped together with that aggregation. So we'll continue to do that until they're all assigned. And then the places that they're not assigned to anything, they're either going to be outside of a 2010 urban area, they'll be completely within a 2020 low density fill, or they have multiple intersecting areas. We're going to assign them to the aggregation which has the best worker flow relationship. We continue doing that until everyone has been assigned and the urban areas have at least 25% mean internal flow, meaning that the people who live in that area work in that area, and have at least 5,000 persons, so the minimum threshold to qualify. So it's pretty complicated, and those were all just test examples, but we think that having that data-driven approach to splitting is going to be a huge improvement over what was done in the past. In the past, it was a little more arbitrary. We used just the narrowest part between 2 urban areas. So like between here and Baltimore, we picked the narrowest portion of the urban area, or we picked the nearest municipal boundary. So using this approach, we'll have a much more data-driven split as to where the 2 urban areas exist. So naming, we hadn't proposed any naming changes, but when we did the research, we realized that it would be beneficial to include some housing unit criteria with the names. So that will take place with the secondary name. So the primary name is going to stay the same, basically. We're going to use the most populous place, incorporated place, or census designated place. And we're going to utilize that high density nuclei that we've determined earlier. So where the place ends the high density nuclei intersect, we'll pick the most populous of those intersections, and that'll be the primary name. Secondary name is very similar, using the intersection with the high density nuclei, but we're going to use the place with the most housing units, and we can have up to 2 additional names. So another sort of local DC example, Ocean City. In 2010, Ocean City was renamed Ocean Pines because Ocean Pines has a higher year-round population. It had 12,000 people in the 2020 counts. Ocean City had just over half of that, with 6,800, but it has 30,000 housing units. So we wanted to make sure that these places were being captured in the name, places especially like this, where it has such a significant housing unit count for the area, for the urban area especially. So what we're going to do is, in this case, it would depend on what, these are the actual counts for the whole place, because we haven't run this delineation yet, but in the where it oversects with the new delineation, whatever the population counts are or the housing unit counts are, assuming that they are kind of represented as to the overall counts, we would the name for Ocean City would end up being Ocean Pines dash Ocean City. So a slight improvement. Not a lot of people care about the names, but at least they're a little more accurate, and it makes me kind of happy. For our schedule, we've already published the proposed criteria. That was last February. We spent the months after that reviewing all the comments and doing further testing. We've finished writing the final criteria, and we're in the process of getting that published. So we're hoping that that will be February, but probably March at the latest. And that'll be right around the time where we're going to start delineation. So we'll start the delineation process, and then by the summer of 2022, we'll have the next Federal Register notice published with all of the qualifying areas and then the geographies to go along with that. So our team email is geo.urban@census.gov, and the proposed criteria, if you want to read it, is at this link. So.
Great, thank you, Jennifer. We have some questions in the chat for you, and I would also encourage everybody else to take a look at the chat, because while Jennifer was presenting, Michael was able to post some of the answers to the other questions that we didn't get to. So if you're interested in seeing those answers, be sure to check out the chat. But in terms of the questions with respect to urbanized areas, Jennifer, you say that the block qualifies as urban if the block has group quarters with above minimum densities. Is the group quarters information coming from the published redistricting file or from the pre-disclosure avoidance system SAS edited file?
That's a good question. It's coming from, the group quarters is like a flag, basically. It's like a count, how many group quarters are within a block. So we are just taking that from the 2020 block data. That's what we're using for everything, is the block counts. So it would be from that.
Okay. And actually, the next question follows right up on that, which is, when is the expected release date for the 2020 census block boundaries?
That I don't know. I don't work on the block boundaries. We just use them.
I'm guessing that's somewhere on the Census Bureau website.
I would assume so. Yeah, I can see
Okay.
if I can find it.
We will strive to get an answer and we can post it after the meeting. Okay, so the next question is, how does the use of the high density nucleus approach comport with polycentric areas or regions?
I don't have an answer to that.
Okay.
I don't know what that means.
Well, I encourage the original question poser to post a follow-up question to try and make it more clear.
Thank you.
But in the meantime, I'm going to go on to the next question, which is UZA designation, so the urbanized zone system, I think, I'm not sure.
Urbanized area. Yeah, transportation has its own acronyms that Census doesn't use.
Yeah, we do. The designation affects funding and authorization by other federal agencies, particularly US DOT. What is the reaction to these changes by those other federal agencies? And I would actually invite any of the, I know there's a few representatives of those federal agencies online to jump on if they have anything they'd like to add. But of course, I'm hearing crickets.
Yeah. So we've consulted. I would say transportation is the area that we've definitely consulted with the most, and we've worked to make sure that, you know, we always have to say these are for statistical purposes only and not programmatic use. Yet we do understand that they have been used for programmatic uses and funding sources across a variety of reasons. So we have done our best to make sure that you know, the areas that we're creating are going to be useful for our data users, and we have gotten pretty good feedback, I would say. We've met with EPA and transportation, and we haven't gotten a lot of negative feedback about what the outputs are going to be.
Great, thank you. Next question is, do you take the occupancy rates into consideration? I'm guessing that
No.
relates to Ocean City.
Yeah, so we do not, and we did not want to take only the occupied housing units because we are trying to capture a complete urban environment, not just where people were on Census Day of 2020. So we are using occupied and vacant.
Okay. The next question is actually pretty much the same. I think it's going to have the same answer, but I'm going to read it as well. What happens when you have a depopulated urban core where there are dense housing units but not many people? And is that taken into account?
No, it will still qualify as urban. I mean, we have that. If you think about Washington, D.C. and the mall, that's like the heart of D.C., but people don't live there. That is still urban, and we include those areas in the urban areas.
Okay. So this is going back to that earlier question that we had some difficulty with. So the polycentric areas or regions, e.g. Southeast Florida with over 100 small to large municipalities in 3 counties, a region of centers. So let me go back up and find the original question, which is, so how does the use of those high density nuclei, I'm going to say nuclei because it's a lot of little centers, approach the development of the regions? I think that's...
So basically it is just capturing each of those centers. And so it kind of depends on what part of the criteria, like we're using it just to make sure that an urban area isn't just a subdivision, a very, very large subdivision in the middle of nowhere with no downtown core. That's the main reason that we started introducing the high density nuclei. For the naming, it's just a way to make sure that the most populous place that does have a downtown core within the urban area is getting the appropriate name.
Great.
So we could have multiple, like some places will have, you know, DC, you think of how far the DC area extends out. There's going to be lots of high density nuclei within it. So we're going to take just the the ones that have the most populous places for the names, but they're all contributing to the same urban area.
Great. And a couple questions I had missed from earlier. Why wouldn't you use the CCAP data for areas that saw high growth since the last census? So the most up-to-date information is being used. As I recall, the NLCD is dated.
So the NLCD was actually updated in 2019 for CONUS. So that, again, we're just using whatever's the most recent for any of them. So that's why Alaska and CONUS will be NLCD. It's the most recent vintage for both of those. And then CCAP we're going to use for everything else. And that I think is around 2016 for most of them. But it's, again, just what we have available to us.
Okay. And does the calculation for the density requirement exclude water bodies?
It does, yes.
And now we have a follow-up question with respect to group quarters. When you use the 5,000 population criteria, do the population data come from the privacy protected data?
It does. Yeah, we don't have a way around that.
Okay. And the last question we have is, will there be formal responses published to comments on the proposed criteria? And if so, when will that be?
I've tried so hard to get that done, to get that published, and I have met a lot of roadblocks just because it's just not historically done. And I'm not sure if that's going to be possible or not. There might need, they were already heavily redacted to not recognize someone's address or anything like that. They might need to be more redacted to make that happen, and like totally take out any reference to organizations or anything like that. So that is still a work in progress. I'm hoping, but I can't make any guarantees.
Understood. I would love to see the information. I don't care who submitted the comments, but just the key points that are being asked about, and of course the answers to the comments or questions, depending on how they're put into Federal Register. So, and then it looks like we got one last question, which I'm gonna pose before I give it back to Kathy for moving forward to the next presentation. It seems like the shorter jump criteria in 2020 should allow more of the multiple nuclei to be their own individual urban area. Is that a correct inference?
It definitely could be. I mean, if they're not going to connect and they have enough persons or households to qualify, then yeah, they would be their own urban area. That wasn't necessarily a goal of ours, but it was just to make sure that we weren't overextending the urban areas much further than they needed to be. And that was what we had found from 2010, was that the impervious surface criteria and the long jump combined made things extend out much farther than they should be. So that it would be a possibility that you could end up with a new urban area that just didn't connect to what it had formerly been part of.
Great. Thank you so much, Jennifer, both for your presentation and excellent answers to the questions. So I will pass it back to Kathy.
Great. Thank you again, Jennifer. Our next speaker is Charlene Byrd. Charlene is a survey statistician at the U.S. Census Bureau in the Social, Economic, and Housing Statistics Division, Journey to Work and Migration Statistics Branch. She has a doctorate degree from the University of Tennessee Geography with an emphasis in urban and economic geography. Currently, she's specializing in commuting and other transportation-related topics. So Charlene, take it away.
Thanks, Kathy. I appreciate the introduction. And I just want to echo what other folks have said. Excellent presentations from colleagues Michael and Jennifer. For the Journey to Work and Migration Statistics Branch, I just have basically 3 main updates that will be of interest to this group. The first set actually contains 2, and they're both related to the ACS. As many of you know, There were collection issues during the pandemic, and that has impacted the one-year ACS tables and their release. We are releasing experimental estimates for the 2021 year ACS. Traditionally, you would have been able to access them through data.census.gov. That is not the case for the 2020 release. We are releasing 54 tables that cover social, economic, housing, and demographic characteristics for just the nation and state. So a pretty limited portfolio of estimates. Of interest to this group will be tables XK200 and 801. And if that doesn't sound familiar, it's the means of transportation to work tables. And then the second table that will be of interest is the XK200 802, which is the average travel time to work. The PUMS data, or the microdata, have been released. They're released this year with experimental weights, and they are being produced for the following geographies: the nation, regions, divisions, states, and PUMAs. So not that different, I think, than the regular published geographies, but just to echo again, they are the experimental weights. So that kind of contains the first year publication of experimental data this year. The second announcement I probably want to touch on for the group is the release of the 5-year ACS data. As many of you know, it's been pushed. Traditionally, it's come out in December, but the release schedule is scheduled for March of 2022. So just a couple months away. So something for you to keep in mind as we move forward through the year. The second item that might be of interest to this group is an upcoming webinar. It's Wednesday, January 26th at 2 p.m. and it's an hour long. It's Eastern time, and it's on geography areas and concepts for the American Community Survey. So that might be of interest to this group. And then finally, just wanted to touch base and remind folks that there will be new Metro Micro delineations. The Office of Management and Budget are going to delineate the CBSAs in 2023 based on 2020 census data and the 2016-2020 ACS 5-year estimates. You can look for those to take place in June of 2023 if the calendar kind of keeps up with what's estimated. But you can find that information from the Federal Register publication for the new Metro Micro area delineations. And those are kind of the 3 main updates I have for census information. So thanks.
Thanks so much, Charlene. Our next presenter is Penelope Weinberger. Penelope is in her 14th year at AASHTO. Her chief responsibility is the successful operation of the Census Transportation Planning Products Program, and she loves it. Penelope also works with the AASHTO Committee on Data Management and Analytics. She began her 2nd or perhaps 5th career in transportation in 1999. She's a person who rides a bike and is regularly looking for a bridge game. So make sure you email her about that if you're in the area.
Thanks, Kathy, for the introduction. Can you see my screen and can you hear me? I can never tell when I'm presenting.
Yes, we can see it.
Okay. So of course, I'm going to give you an update on the things that I think are interesting, but I see that we're going to be a lot of time left for questions at the end, so we can have those. The first thing I want to talk about are CTPP initiatives, the Census Transportation Planning Products Program. One of the things that we've started doing a lot in the past couple of years is focusing on online delivery of everything, just like everyone else has. And I'm really happy and proud to say that we've done a major update of the CTPP website. So if you haven't visited it in a while, it's probably worth visiting. The URL is going to be on the last slide, but it's ctpp.transportation.org. We've initiated or we've started a series of online training. And what we're doing is every single month, we have a rotation of 4 different types of presentations that we're doing. So once a month, we do one of them. This coming month on January the 19th, I think it is Wednesday, we'll do software basics. And then we're going to do software advanced in February. And then in March, we'll be doing getting to know the CTPP data. And then the 4th month is a spotlight series. I'm going to come back to that later. But if you go to our website and you look at our training, you'll see the monthly live online training. Click on that box. It'll describe the 4 trainings that I just mentioned. It'll offer you a link for registration. And it offers you an opportunity to sign up for notice of what is coming. So what the spotlight series is going to be on, for instance. And that's really fun. Our website also has all our old e-learning tutorials are available there on our website and also on the AASHTO store. So those are the interactive online learning modules. We're developing a new one on equity analysis. That's been a long time coming, but we're finally talking about how to use the CTPP to help with your equity analysis. We know that's still very important. So the Spotlight series that I mentioned, we did our first one in December. It was super exciting. It's the one training that we're recording. We'll eventually get to be recording the other 3, but we're waiting to smooth the bugs out a little bit and make sure that we have them smooth. But since each Spotlight series is going to be different, we are going to go ahead and record those right away. So the first one we did was in December, and it was on the Commuting in America series. The Commuting in America series is sort of a series. Right now it's a series of briefs. It used to be a giant book, maybe you recall, from the first 3 editions of it, and then it moved to a series of briefs, of topical briefs. We've published 2 in the last year, one on the changing nature of work and one on vehicle availability patterns and trends. We have 3 more that are very close to finished that we're about to put through publications. And that was what the Spotlight series was, talking about those 3 research efforts on commuting briefs. One was on the evolution of households, one was on change and variation in commute mode, and one was on emerging modes and how to measure them. We just got a first draft on our 4th Commuting in America that should be coming out in the coming year. And that is going to be on, it's a sort of a mashup of machine learning and disability data. So that's going to be really interesting. We know we don't have a lot of information on commuting, disability commuting. So differently able people, disabled people commuting. And later this afternoon, after this meeting is finished, we're going to have a discussion, a small discussion private within the group on what our topics for the next few Commuting in America briefs are. So if you get a chance, if you have a strong idea about what you think they should be, please shoot me an email before 3 o'clock today, and maybe we'll be able to get that information into the hopper. I'm going to come back later and talk about other research that we're doing. But one thing that I want to talk about next is in June of this coming year, this year, 2022, we're all going to go to Reno, and we're having a conference there, Census Data for Transportation Planning Conference that we typically have every 5 or so years. We're trying to do them more often. This past couple of years was when we were going to finally get them to be every 3rd year, but we didn't because of COVID. So now we've pushed this back to June. Hopefully it will be happening live and in person. We expect it to. One thing that's going to be a little bit different from this conference, about this conference from conferences in the past, is that it's going to focus more, have more offerings of workshops and learning exchange. That seems to be what's called for right now. So registration's not yet open for this conference, but it will be soon. Keep your eye on the CTPP website to see when that goes live, or join the CTPP listserv, which is in its new location at CTPP. If you go to listserv.transportation.org and find the CTPP listserv, you'll get notice of all the great things that CTPP is always doing. So other efforts that are happening at the CTPP right now, we have a tab request into the Census Bureau for our next data set, which is going to be based on 2017 to 2021 data. Yeah, that's right. And we realized, and of course what Charlene said about all the problems with collection, there were a lot of problems with data collection, not just in the pandemic years, but also in 2019 when there was a government shutdown for collecting the ACS. So we're looking at this data set as a kind of a baseline data set for how to move forward. What's transportation going to look like? What's commuting going to look like post-pandemic if we ever get there, hopefully. So that request is in front of the Disclosure Review Board right now, and we should be hearing sometime soon whether it's been accepted or not. We're doing a bunch of different research efforts. One is a utility project. It's kind of an update to the utility of the Census Transportation Planning products data that we often do. One of the things that is kind of special about our data set is that we like to tell you everything that's wrong with it, along with giving it to you for free. So we're not like the other guys. We're not going to tell you it's good for everything. We're definitely going to tell you how to make sure that you're using it right based on its limitations. So, but we do want to make sure that it's useful. So we are reaching out to MPOs, we're reaching out to the states, we're asking people, we're looking at the data, we're analyzing the data, always trying to make things better. We have had a solicitation on the street. It closed for a new software to deliver a data access software, which should include an API in its next iteration, along with all of its regular web-based user interface and great mapping. I don't have a lot to say about that now because we haven't selected who the next developer will be. We did an effort recently to gather a list of Mpo liaisons. These are state DOT staff who are the liaisons to MPOs, because CTPP is housed at AASHTO, which belongs to the, which is the Association for the State Departments of Transportation. It's important for us to make sure that we can reach everybody. And one of the gaps that we noticed is that even though we have a great working relationship with the National Association of Regional Councils and AMPO, sometimes we still don't get the information out to the MPOs. So we started an independent effort to gather information on MPOs, liaisons at the state DOTs, so that we'll have another tool to get information out. So we're kind of excited. We have a response from 30 different states so far. We'll track down the last 20, hopefully. We have another couple of research efforts going on that I want to mention. We did some research on the long-term impacts of COVID, and we have a big TRB and NCHRP project on a guidebook for census data that are coming out. I know that Krishnan Vishwanathan is on this call, and I know that he was not asked to speak, but if you could, Krishnan, do you want to turn your microphone on and tell us a little bit about those two research efforts for a moment? Now we get to see whether Krishnan's paying attention. He is here, right? I did see him. Okay, well, I guess I'll give him a break. So that's pretty much everything that I thought was interesting that you might be interested in. Here's our fabulous logo. Here's our website, and I'd be happy to take any questions or answer any questions about the CTPP program. Oh, I didn't actually, I'm sorry, I jumped the gun. I do have some other things to say. So the CTPP is a technical service program of AASHTO, and therefore it's has two parent committees, and one is the Committee on Planning and the other one is the Committee on Data Management and Analytics. And there's a big change at the Committee on Data Management and Analytics because our chair, Secretary Greg Slater of Maryland, is leaving state service. So right now CDMA is on the hunt for a new chair. Trying to think if there's anything else I want to say. Oh, and there are a few other conferences I wanted just to mention. One is GIST, which is coming up in April. So those of you data people who are also interested in geography should look for the GIST Symposium, Geographical Information Systems in Transportation, and get on down to South Carolina in April 17th to 22nd, I think that is. And then much later this year in 2022, in December, the Committee on Data, the parent committee of CTPP and Planning, and the Committee on Performance Management, those three AASHTO committees are having a joint conference in Providence, Rhode Island. So that's really it. Are there any questions?
We don't have any questions right now in the chat, but we did receive one for Charlene earlier that she actually answered in the chat, which is, you've mentioned experimental 1-year ACS data. Will there be a non-experimental 1-year ACS data set released later? And the answer is no, just the 1-year experimental data set. And so at this point, I'm going to kick it back to Kathy for sort of our final announcements, and then we're going to open it up a little more freely to questions on any of the topics, of which we have a couple in the chat, but I'm going to give it to Kathy.
And actually, I'm going to kick that to Mike Fontaine. Do you think you could tell us a little bit about, oops, sorry, just moved here. Mike, do you think you could speak about the upcoming sessions at the 2022 TRB annual meeting?
Sure. Thank you, Kathy. I guess, first of all, I want to thank Clara and Kathy for just really a great subcommittee meeting. It was made me very happy to see over 200 people at the peak online here. So I think we had a great session and really good presentations by the speakers. So for those of you that are online, the Urban Data Committee is the parent committee for this subcommittee. We do have a number of activities that are planned to take place in person at TRB this year, if you will be going there. So you can see we start off with a workshop on Sunday focused on equity considerations and big data in an urban and regional context. And this is sort of a companion workshop to another one that's happening in the morning that our statewide data committee is putting on. For those of you that will be there in person at TRB, we are planning to have an in-person Urban Data Committee meeting on Tuesday between 1:30 and 3 o'clock. As probably everybody on this call can guess, there has been some major changes in agendas and schedules just because a lot of folks have chosen to opt out of TRB because of the combination of COVID concerns and a lot of the travel difficulties folks are encountering these days. So one of the things that we're going to do is, while we will have an in-person committee meeting on Tuesday, we're also going to set up a companion virtual committee meeting that's going to occur at some date to be determined after the annual meeting is over. If you are going to be at TRB, I guess the one thing in particular I want to point you towards is on Wednesday between 10:30 and noon, we have 3 poster sessions going on that are covering sort of all aspects of urban data, including a lot of things that are related to some of the census data issues that we've heard about here today. So with that, again, appreciate everybody's attendance today, and I hope to see some of you at TRB in person. And if not, I totally understand why you did not make the decision to go to TRB this year. And hopefully things will be better in 2023. I feel like I'm the cursed chair of the Urban Data Committee, where last year the Capitol riots happened while we were doing the Urban Data Committee meeting. And this year we've got Omicron to worry about. So I partially fear for myself a little bit about what is going to happen next year during the Urban Data Committee. But hopefully everything will be smoother. I feel like I've been saying that for about 3 years now. But thanks again, Kathy and Clara, for all of your, Mara is suggesting a Sharknado. Okay, I would like to see that. So thanks everybody, and I'll turn it back to Kathy and Clara.
Thanks, Mike. I think you're also getting a plug for a comet hitting the Earth. Hopefully none of those will happen either this year or next year during the Urban Data Committee meeting. But again, we want to thank everybody for coming and for the great presentations from our presenters. And just to reiterate, we will be happy to share the presentations. If we're going to share it on our friends list rather than posting them to the various listservs, just so we don't spam anybody who's not wanting to be spammed. And we know you may not want to put your full email address in the chat, so please send either Kathy or me or both of us an email indicating that you want to be on the list, and we'll be happy to share those presentations with you. I'm sort of trying to go back through the chat, and there's been a few questions and comments that have been posted up here. There's a question about the block group geography, replacing the TAZ's geography in the future C2BP data products and what that will look like. And the response is that we're still waiting to find out if the Census Bureau's Disclosure Review Board will allow for Block group geography to be the smallest geography. TAZs are not going to be tabulated. So really the question is, what is the smallest of the standard geographies? We've asked for block group. The next step would obviously be the tract geography. So I guess the longer answer is stay tuned for more information as we move through the Disclosure Review Board process on the next CTP tabulation. And also I would draw your attention to the chat. Charlene has posted more information about the one-year ACS. There's a link in the chat at 12:42 p.m. For you to find out more information. And so now we have a couple questions that I'm going to post that I think are a little more general. And then if anybody has questions after that, I'd invite you to actually raise your hand in the Zoom, which is under reactions down at the bottom of your screen. So the first question I have here is, given the understandable need to pare back the 2020 ACS 1-year data set, are the Census Bureau and AASHTO comfortable with including the 5-year ACS data that includes 2020 as one of those years? And I guess I'll open that up to either Charlene or Penelope as to who feels more comfortable answering that one.
Well, since I'm unmuted, I guess I'll take a whack at it. I'm not sure I really understand the question, Kevin, that you're asking, but we're including the 2020 data year in our next data request. So we, for what it's worth, we're planning on using it. Even with all of the problems in data collection, the census data far outweighs any data collection effort by any other data set. So even if it's not as robust as it used to be, and we all are very sad that we're not getting 17% anymore, it still is a larger, more robust data set than any other data set.
And I would actually add to that, that the ACS data was collected in 2020, but not when the country was as close to shutdown as it was in the spring. So my expectation is the data that is collected in 2020 will be not as heavily impacted from a commuting standpoint as any data that would have been collected in, say, April and May of the 2020 year. So we'll just have to see how it ends up coming out. And okay, those are the questions that I see in the chat. Like I said, I would like to open it up to anybody who would prefer to ask a question verbally, to just do a quick raise your hand in the using the reactions at the bottom of the screen, and we can answer them as best we can, from all the presenters and anybody else on the call. Just get a little bit of conversation going, since that's the one thing we're really missing with a virtual meeting. Oh, we have Mpo Liaisons. Like to ask you to unmute and ask your question.
Okay, so this is not a question. Just I heard like you guys were talking about you haven't got approval for the census block group that's the lowest finest level of NEST CDBP data. I just want to give you some information from our small MPOs, because census groups are really important. Block groups are really important for us because tracts are really too big for us in our model development. So if you guys can push that to block groups at the lowest level, I would really appreciate that. Thanks.
Thanks, Jimbo. We absolutely asked for block groups, and in the past, and Christopher likes to remind us, we've even gotten block level data from the Census Bureau, but it's all up to what the Disclosure Review Board will allow. So fortunately, we've got very good partners at the Census Bureau who are going to bat for us and preparing our package for the DRB, and Nick Spanos and his group. And we know that they're going to work really hard to make sure that we get obviously what is the most usable data, because we've been down the road before, and we know that if the smallest level geography is too big, then it's not useful for the MPOs. So we hear you.
Okay, thank you so much.
Are there any other comments, questions, concerns? David Heller, go ahead.
Yes, just real quick. At the beginning, you showed I guess the group, the different census products that you're scheduled to release. And I believe, was it just of those products, was it just what was released? Was it just like the reapportionment data that was released? I missed that. I just want to make sure I got that detail.
So I can take that. So the only products from the 2020 census that have been released so far were the apportionment counts. So those were the state population counts that were used to apportion seats in the House of Representatives. And then that was back in the spring. And then in August, we released the Public Law 94-171 redistricting data summary file. That's the block level population counts, race, and race by Hispanic or not Hispanic. So tables P1 through P4. So those came out in August. The next big release, as I mentioned, is going to be the demographic profile and demographic and housing characteristics file, which will be released later this year.
Thank you very much.
Okay, not seeing any other comments, questions, or concerns, either in the chat or through hand raising. I think this pretty much concludes our subcommittee meeting. We thank you all for coming. This has been a great turnout, and I know I learned a lot from Michael and from Jennifer, as well as from Charlene and Penelope. So I urge you to sort of stay tuned to learn more about where the Census Bureau is going with terms of releasing data that we can use for transportation planning and other processes. And if you're going to the annual meeting next week, there's lots of great opportunities to learn more about how the data is used in a practical sense. So we definitely encourage you to participate with those meetings to the extent that you're comfortable doing so. And one last call, if you wish to receive presentations, send us your email, either through the chat or through email to Kathy and me, and we'll send those out in the days to come. So again, thank you so much for your time and attendance. Kathy, do you have any last?
No, just hope everyone has a happy and healthy new year.